You're going to finish up this chapter 9 homework 9.3. I'm working in 9.3, number 13. So we have that r is equal to 2 cosine theta. And the instructions here are to identify the curve by finding the Cartesian equation for the curve. So we want to try and convert this curve from polar to Cartesian. And what we know is, as far as the relationship between the two, is that x squared plus y squared equals r squared. We know that x equals r cosine theta. This marker's dead. We know that y equals r sine theta. And we also know that theta is arctangent of y over x. So these are all the relationships we have. And I want to get this over to Cartesian. So I want to switch this in terms of x and y. So here's what I can do. I can rewrite this as r equals 2, and then remember cosine theta. If we solve this for cosine theta, we can divide both sides by r. So cosine theta should be x over r. And now, if I multiply both sides by r, I know that r squared is equal to 2x. So that's just multiplying both sides by r. And I know that r squared is x squared plus y squared. So I have x squared plus y squared equals 2x. And then if I move the 2x to the other side, I get x squared minus, if I move the 2x to the other side, I get x squared minus 2x plus y squared equals 0. And this is a Cartesian equation. However, I don't recognize it right off the bat because they're trying to get us to identify the curve. So like try and tell us what it is without actually trying to graph it in polar. So what I'm going to do next is kind of tricky. I'm going to take these first two terms here and I'm going to complete the square. That means I'm going to take the number in front of x, which is -2. I'm going to take half of that, which is going to be -1, and then square it. So if I take half of -2 and square it, I get a 1. So what I'll do here is I'll write x squared minus 2x. Now remember I had a 1, so I'm going to add and subtract a 1 at the same time. So that's a little hidden 0 here. Then I still have plus y squared equals 0. And the reason I complete the square is because this here, these first three terms, are guaranteed to factor. Actually, it factors to be x minus 1 quantity squared, and then minus 1 plus y squared equals 0. Then add 1 to both sides. And this right here is something that we should be familiar with. Remember, we have the general formula for the equation of a circle. This is the equation that we use for a circle that has a center of hk and a radius of r. So if I come back up here, I notice that I have x minus 1, so h here for me is 1. And since this y is by itself, there's no minus k, I can assume that the k is 0. And then this is the radius squared, so I know that my radius is 1. So this is the equation of a circle that has a center of 1, 0 and has a radius of 1. So that's your curve. All right, now number 14, no, not 14, number 47. So for 47, we are given a polar function. The polar function is r equals 2 sine theta. And we are given that theta is pi over 6. And we are asked to find the slope of the tangent line to the given polar curve at the point specified. So we need to use the formula for the slope of the tangent line. We know that the slope of the tangent line is dy dx, and then in class and in your notes, I gave you the formula for this. This is going to be dr d theta cosine theta plus r, oh sorry, oops, I messed that up already. Sine theta plus r, and then we have cosine theta over, over dr d theta, and then here's where we've got cosine theta minus r sine theta. Okay, so that's our formula. So what we need to do is in this formula, we need to replace dr d theta here and dr d theta here with the derivative of this, and replace r here and r here with 2 sine theta. So this becomes, well, the derivative of r with respect to theta is just 2 cosine theta. So I have 2 cosine theta sine theta plus r, which is 2 sine theta, times cosine theta, over, now the derivative with r with respect to theta, yeah, that's right, okay. Derivative again, that was 2 cosine theta, but this time times cosine theta again, and then minus r, which we know is 2 sine theta, but times sine theta. All right, now we could try and clean this up. It actually does clean up a little bit, but I just need to plug in pi over 6 into all this. So let's just plug in pi over 6. At theta equals pi over 6, dy dx, the slope of the tangent line will be 2. Now, remember, pi over 6 is right here. It's 30 degrees, and we have as an x-coordinate root 3 over 2 and a y-coordinate 1/2. So when we say cosine theta, we want the x-coordinate, so root 3 over 2, times sine theta, which is the y-coordinate, 1/2, plus 2 times sine theta, which is 1/2, times sine theta again, which is 1/2. All over, cosine theta, oops, this was cosine theta, root 3 over 2. And then on the bottom, cosine theta is root 3 over 2, but then times itself, that means square it. So I have 2, and then root 3 over 2 times root 3 over 2 is 3/4. Then minus 2 times, now sine theta is 1/2, but we're squaring it, so 1/4. So let's try and clean things up here. These 2's cancel, these 2's cancel. Here we just get root 3 over 2, here just root 3 over 2. So we have root 3 over 2 plus root 3 over 2. I'll combine those again in a minute. And then here, in this, we get 3/2 minus 1/2. 3/2 minus 1/2 is just 1. So we have a 1 on the bottom, so I don't need to mess with it. Put these 2 together and you should just get root 3. So the slope of the tangent line at pi over 6 should be square root of 3. It's not asking us for the equation of the tangent line, just the slope. Okay. What's next? 49. Our function of theta is 1 over theta, and they want us to look at the point theta is pi. So we're going to use this same formula here. The only thing that's going to change are these derivatives and then what the r function is. So let's take the derivative of r with respect to theta. Remember, this is the same as theta to the -1. So we're going to do a power rule on that. We're going to get negative theta to the -2. That's our derivative of this, times sine theta, plus r, which is just 1 over theta, cosine theta, over, then the derivative again, negative theta to the -2 times cosine theta, minus r, which we already know is 1 over theta, and then sine theta. Now, I could leave it like this. Just remember that this right here is really -1 over theta squared. right? This is really negative 1 over theta squared. So let's go ahead and plug in pi now. So at theta equals pi, dy dx will be equal to, okay, this will be negative 1 over pi squared times sine of pi. Well, sine of pi is 0, so that's gone, plus 1 over pi, and then cosine of pi is negative 1. So we've got that so far. And then here, we get negative 1 over pi squared times cosine theta. Cosine of pi is negative 1 minus 1 over pi times sine of pi, which is 0. So this is gone, this is gone. I get negative 1 over pi here, over here I get negative and negative is positive, so we should get 1 over pi squared. And then when you flip and cancel a pi, you should get negative pi. Let's just double check that there. Yep. Okay, so the slope of the tangent line is negative pi. Again, we're not being asked for the equation of the tangent line, just the slope. All right, number 51. We have the curve r equals 3 cosine theta. And we want to find the points on the given curve where the tangent line is horizontal and vertical. So first we need the derivative. Let's find the derivative. Should have just left that formula up here. Okay, so there's our formula. And now we just, again, take derivatives here. So the derivative of r with respect to theta is going to be negative 3 sine theta, but then times sine theta again, plus r, which is 3 cosine theta, times cosine theta again, over, on the bottom, derivative of r with respect to theta, we already did that. That's negative 3 sine theta times cosine theta minus r, which was 3 cosine theta times sine theta. Now I'm going to clean this up just a little bit. This is negative 3 sine squared theta plus 3 cosine squared theta. That's almost an identity, but not quite because of the signs. And then on the bottom, I have negative 3 sine theta cosine theta minus 3 sine theta cosine theta. These are identical, so I put them together, I should get negative 6 sine theta cosine theta. And I'll do a little more cleaning up here. Let me just cancel out a factor of 3. Actually, let's cancel out a factor of negative 3. So I'm going to divide everything by negative 3. And if I do that, I should get sine squared theta minus cosine squared theta over, let's see, I factored out, so 2 sine theta cosine theta. Now there's other identities we could use right now to clean this up, but I'm just going to leave it like this and now answer the questions. So what points on this curve give you a horizontal tangent line and then a vertical tangent line? So let's talk about the horizontal first. I'm going to need that curve. R equals 3 cosine theta. So first of all, horizontal, what we want is this to be 0. So we just need the top to be 0. We need sine squared theta minus cosine squared theta to equal 0. And that's only going to happen if sine squared theta equals cosine squared theta. And you could go a little bit further here. You could divide both sides by cosine. But I'm going to do this a little different. We're basically saying, if I take, let's say, the square root on both sides, I'm going to sine theta equals plus or minus cosine theta. So you take the square root over here, square root goes away, take square root over here, square root goes away, but you have to do plus or minus. So what this is saying is, where on the unit circle, okay, to make this equation true, where on the unit circle is sine equal to cosine, or is sine opposite of cosine? Where do they have the same value, or where are their values different just by a sign? So let me see here. At 45 degrees, okay, so pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. At these points, let's see, we have root 2 over 2, root 2 over 2. Here we've got root 2 over 2, sorry, negative root 2 over 2, root 2 over 2. And then here at this one, we have negative root 2 over 2, negative root 2 over 2. And then here at this one, we have root 2 over 2 and negative root 2 over 2. So what you can see is that at each of these 4 points, the sine and cosine, which correspond to the x and y coordinates, are the same. Here they're off by sine, here they're the same, here they're off by sine. So it's these 4 points where we're going to have this equation be true, which means we should have horizontal tangent lines. So we need to somehow represent these solutions. The solutions are going to look like this. My theta must be this angle right here, which is pi over 4, plus, now to jump around, to get to the next one, I add pi over 2. Then another pi over 2, then another pi over 2, then another pi over 2. And so I can get to all of them by just adding multiples of pi over 2. And if I get a common denominator here, I get pi plus 2 pi n over 4. So that's what happens if I get a common denominator. And now I just let my n cycle. I better leave this here. I'll let my n start to cycle through different numbers. So let me start to list these out. If n is 0, I get pi over 4. If n is 1, I get 3 pi over 4, 5 pi over 4, 7 pi over 4, and so on and so forth. So all the odds. And now, to figure out the points where I'm going to have these horizontal tangent lines, I need to plug those values back into the original function of r, or function of theta. So here are my points, the points where this is going to happen. Well, plug pi over 4 in. You have r equals 3 cosine of pi over 4. Cosine of pi over 4, we can go back to our unit circle. Cosine of pi over 4 is root 2 over 2. So we get 3 times root 2 over 2, which is just 3 root 2 over 2. So if you look at this as a point, a polar point, the r is 3 root 2 over 2, and the theta is pi over 4. Right? And then if I try and plug in 3 pi over 4, the radius will be 3 times cosine of 3 pi over 4. So when I'm at 3 pi over 4, here cosine is this, it's negative. So I'm going to get the same answer as before, but negative. And then as a point, it's going to be negative 3 root 2 over 2, then 3 pi over 4. And then when I do 5 pi over 4, cosine, I'm going to be down here, I'm going to get the negative again. So this is happening, right? This point right here, same thing is going to happen here and here, right? Those two are going to give you the same point. But when I do this one and 7 pi over 4, so 7 pi over 4 is right here, cosine's positive again, just like it was up here. So these two will give me this result. So they go in like weird pairs, but these are the only 2 points on the curve that will give you, that you'll have a horizontal tangent line. Because as you move out in this list, you're just going to start repeating these points. They're going to be on top of each other. All right, that was number 51. They didn't give us a number, yeah. Okay, now next. Where is it vertical? Vertical. Well, we will have vertical tangent lines whenever the denominator of the derivative was 0. So this right here, we have to set that to 0. So 2 sine theta cosine theta equals 0. So just divide both sides by 2, it's gone, and then just set each of those equal to 0. So sine theta equals 0, and the other one is when cosine theta equals 0. And sine of theta is 0, unit circle here. Sine's your y coordinate, that happens here and here. Cosine of theta is 0, your x coordinate is here and here. So if I combine both of these together, my general solution here is going to be that theta must be my starting angle, which is 0, and then I just have to add pi over 2 to move around. So I could just say pi over 2 n, and then just start cycling through n's. So I could have pi over 2, oops, I could have 0, I could have pi, 3 pi over 2, 2 pi, dot, 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 I keep going. But I'm going to start plugging these into our function and see what points come out. And we should start to get the same points over and over. Whoa, what happened here? Whoa, that's weird. It's like my pen blew up or something. Wow. I haven't seen that happen before. That's strange. Is there something on here? There must be something on this. All right, so start plugging those in. I'll get r equals 3 cosine of 0. Cosine of 0 is 1. So we just get 3 for r. And then remember, we plugged in the angle there was 0, so 0. R equals, let's plug in pi over 2. So 3 times cosine pi over 2. Cosine of pi over 2 is going to give you 0, right? So we're at pi over 2. Cosine of that is 0. So we just get 0 for the radius, but remember we plugged in pi over 2. And then r equals 3 cosine of pi. Cosine of pi is negative 1. So we get negative 3 here for our radius, and then pi, like that. And let's go one more. If we go 3 pi over 2, r, 3 times cosine of 3 pi over 2. Cosine of 3 pi over 2 is 0, so I get 0 at 3 pi over 2. So if I try and visually see where this is happening, this would be happening at, let's see, aim out at an angle of 0, which is here, and walk out 3 units. That's 1 point right there. Here, aim out pi over 2 and walk 0, which would be this. Here, aim at pi, then walk out negative 3, so that puts me back here. And then this one, aim at 3 pi over 2, which is down, and then don't walk anywhere. So it's just these 2 points over and over is what's happening. So we should have vertical tangent lines. And yeah, that's it. Make sure we got this. 0, 5, 2, yeah. Okay. Number 53. Is this my last one? Oh, it's the last one for this section? No, it can't be. Yeah, last one for this section. So for 53, wow, what is going on with this thing? It's like these markers on this board are just acting weird. I think they're done. They're done with the semester. They don't want to do anymore. Okay, 53. R is 1 plus cosine theta. And I need my derivative, so dy dx equals, I'm not going to write the formula down. And just Okay, so we have derivative of this with respect to theta, negative sine theta times sine theta plus r, which is 1 plus cosine theta times cosine theta. Okay. I always have to check it just in case. And then the derivative again, negative sine theta, and then cosine theta minus r, 1 plus cosine theta times sine theta. And I'll do a little cleaning up here. This is negative sine squared theta on top. And then here, when I distribute, I should get plus cosine theta plus cosine squared theta. And then on the bottom, put those two together, or just, I guess there's nothing to do there, just write them. Distribute here and then pass the negative through. So negative sine theta and minus cosine theta, sine theta. So sine theta, cosine theta. Okay, that's my denominator. Unfortunately, those don't really clean up that much more. Let me just leave it like that. That can be messed with later, but I'm going to basically take this, set the top to 0 and bottom 0. So where's my tangent line horizontal? Well, I set negative sine squared theta plus cosine theta plus cosine squared theta equal to 0. And this is not a simple equation to solve. You have to realize back from pre-cal that this is a quadratic. And so we need to basically get everything in terms of the same trig function. So I'm going to replace this with something. So remember, sine squared theta is 1 minus cosine squared theta. But I have negative sine squared theta, so if that's negative, then this becomes minus and plus. So this right here turns into cosine squared theta minus 1. I just changed the order of these two because the signs changed. So there's my, this piece, then plus cosine theta, and plus cosine squared theta equals 0. And now I have two like terms. I can put these two together. 2 cosine squared theta. I have plus cosine theta, then minus 1 equals 0. This is a quadratic form trig equation. So I should be able to factor this. Let me try it. 2 cosine theta, cosine theta. I need a positive in the middle, so I'm going to go plus 1 and minus 1. And just double check. 2 cosine squared theta. 2 cosine theta, take away a cosine theta is cosine theta, and then negative 1. So that works. Set each of these equal to 0. So when I set this equal to 0, and set this one equal to 0, I should be able to get some general solutions here. So this is going to be cosine theta is a half, and this one is cosine theta is negative 1. And now some general solutions. Where is cosine theta 1/2? Cosine is the x-coordinate. I need it to be positive 1/2. That happens here, and that happens here. So that's, theta can be pi over 3 plus 2 pi n. So there's no way to get from this one to this one easily. So I have to start at pi over 3, and then I have to come all the way back, and then all the way back. So that'll take care of all those. And then I also have this one right here, which is 5 pi over 3 plus 2 pi n. Those will give me, those are these two solutions, the general solutions for this one. Cosine theta is negative 1, that's this point, and that's just when theta is pi plus 2 pi n. So you start out at pi, and then you go back, start out at pi, go all the way back around, all the way back around, so that's this. Whew. All right, I've got to take those and I've got to plug these into this right here. And I'll need this derivative. I actually am just going to need the bottom piece right there. So let's try plugging in, let's go pi over 3. So if I'm at pi over 3, that's right here, then what happens to this? So r becomes 1 plus cosine of pi over 3. Cosine of pi over 3 we said was a half. So this is 1 plus a half, that's 3 halves. So as a point, we're getting 3 halves for the radius and then pi over 3 for the angle. Now let's plug in 5 pi over 3. So r 1 plus cosine 5 pi over 3. Well, cosine of 5 pi over 3 is the same as cosine of pi over 3, so you're going to get the exact same answer, 3/2. But that's happening at 5 pi over 3. And then finally, pi, let me try pi getting plugged in. Again, I don't want to erase that. R is equal to 1 plus cosine pi. Cosine of pi is -1, so you get 1 minus 1 is 0. So this is going to give you the point 0 pi. All right. Let me try and show this graphically where these points are. So on my curve, if I were to sketch this polar function, then when I'm at the point, let's see, let's do this one because it's easiest. If I rotate pi and then don't go anywhere, that point should be on my curve, and the slope of the tangent line there should be horizontal. If I go and rotate by pi over 3, which should be, if this is 45, pi over 3 right here, and I walk out 3/2, which is 1.5, I should have a horizontal tangent line there. And then if I do 5 pi over, oh, I said pi over 3 is not there, sorry, pi over 3 is up here. That's pi over 6. So rotate by pi over 3, walk out 1.5, that's where I'd be. And then rotate 5 pi over 3, which would be down here, walk out 1.5, I should have horizontal tangent lines there. It would help if I graphed it so I could actually see it, but I don't have the graph right now. So, okay, next thing. You know what? I'll do the graph real quick. That way we can see, we can be convinced. So I'm just going to do my polar. I need to zoom in a little more. This is a weird one. It looks like this. That. So if you look at the slope of the tangent line here, it's 0. Slope of the tangent line here is 0. And then look at the slope of the tangent line here. It approaches 0, bam, right at the origin at 0, and then it goes back out. So slope 0, right in there. Pretty cool. All right, now to figure out where the tangent lines are vertical, I should get an answer here, here, and here. Vertical tangent, vertical tangent, vertical tangent. But let's do it with the algebra here, or the calculus, I should say. Well, we've done the calculus. We just need to do algebra. So I need to figure out when the derivative, when the denominator is 0. So let me take that denominator. Let me set it equal to 0, see what happens. Okay. What a mess. Let's just get rid of the negative signs. Multiply everything by -1. So that's now positive, that's now positive, that's now positive. Now let's put these two together. So I have two, because they're like terms. So 2 sine theta cosine theta plus sine theta equals 0. Another trig equation, just factor a sine out. This one, you don't have to do any messy quadratic stuff with it. And then set each of these equal to 0. So you get sine theta is 0. In the other equation, you'll get cosine theta is -1/2. And solving this one, you get theta is sine, your general solution, sine, it's here and here. So you can just put pi in. And then here, cosine is -1/2, puts us here and here, which is going to be 2 pi over 3 plus 2 pi n. So you go to here, and then you have to go all the way back around, all the way back around. Then you have another one, 4 pi over 3 plus 2 pi n. So all I really need to do, don't erase that, keep that up here, is plug in, let's see, this is really like 0 pi, 2 pi, 3 pi, 4 pi. So I'm just going to plug 0 into this. So r equals 1 plus cosine of 0. Cosine of 0 is 1, so you get 2. So that means you have a radius of 2 at an angle of 0. Then for this one, I'm just going to go 2 pi over 3. 1 plus cosine of 2 pi over 3, which is going to be 1 minus a half, which is going to be a half, which means we have 1/2 at 2 pi over 3. And then plug in this one, 4 pi over 3, which also gives you negative 1/2 here, so you should get half. So let's try and plot these. So if I rotate by 0 and walk out 2, so rotate by 0, walk out 2, 1, 2. At this point right here, I should have vertical tangent. If I rotate by 2 pi over 3, which would be somewhere over here, and then walk out a half, right there, I should have my vertical tangent. It's not perfect, this drawing isn't perfect. If I rotate by 4 pi over 3, which should point me down this way, and then walk out a half, I should be on the other vertical tangent. That's it. Good, good. We're done with 9.3. Oh shoot, I have class in 10 minutes. I gotta go.